Hello everyone, welcome to this introduction session on the Ascend Hardware Edge platform. I'm going to start with an overview on edge computing, followed by some details on AI processors, the CANN software stack, and the Atlas AI Developer Kit. So what is edge computing? Edge computing is a technology where data is processed on the device itself or by a local computer or server. That is, processing power is decentralized rather than being transmitted to and from data centers. So why do we need edge devices? Edge devices address the issues of data transmission latency, privacy, and provide greater device autonomy. When using AI in scenarios like security cameras, autonomous cars, drones, etc., data security can be a big concern for people. With Edge AI, though, as you're processing data locally, the problem can be avoided with streaming without uploading a lot of data to the cloud, which can make you vulnerable from a privacy perspective. Processing time is also greatly reduced, which reduces the risk of data getting tampered during transit. Let's look at an example. For detecting intrusions in a high security area, we especially do not want tampering or unauthorized access. With edge devices, hackers would need to get into decentralized storage systems to access sensitive information, which makes tampering way more difficult. Emergency services is another potential scenario that could also leverage on-site edge computing. As an example, important information can be transferred from an ambulance to a hospital in real time. Since medical data is classified as personal data, this type of analysis needs to happen at the edge. These types of services could become important to build smart cities because it's less prone to massive system-wide failures or data breaches as compared to a centrally controlled cloud computing system. Now we know that AI algorithms require large amounts of processing power, which is why most of them have to run via cloud services. With AI chipsets, though, we can have much better real-time responses within applications that need instant decision-making, like pedestrian detection for self-driving cars, for instance, which can be time-critical. Without edge computing, imagine that a pedestrian detection algorithm would need to run through a cloud-based service, which would take a lot of time to process. Again, for a healthcare scenario, anomalies can be quickly detected with a rapid response time that can actually save lives, making the industry more reliable. Especially for patients located in remote areas, this type of response can be life-saving. Robotics and video equipment can also assist doctors in performing surgery. Edge can also overcome the dependency on network connections, which can be a disadvantage with cloud systems. So we can prevent network breakdowns, etc., and generally offer more reliability. Next, let's consider the costs of data communication and bandwidth requirements. Cloud-based processing can turn out to be quite expensive, so companies can save money by having the processing done locally. Another advantage of edge devices is that they can help with location flexibility. For example, mining companies often need to go to remote locations to find and extract scarce raw materials and conduct all its operations, and they often need to perform on-site real-time evaluations. Later in the presentation, we're also going to take a look at some examples in the manufacturing sector where edge devices can help with performing intelligent quality inspections, such as in a power grid. Now let's take a look at some examples of edge-based product use cases in the industry. With the introduction of 5G networks, we expect rapid growth of IoT-connected devices, which would generate lots of data. And all of this high-volume data cannot be immediately sent to the cloud, so compute on the edge becomes important. For example, we could create intensive care, closed-loop systems that maintain critical physiological parameters, such as blood pressure, etc., within a specific range of values. Activity monitoring is another use case in enabling assisted living to quickly detect anomalies such as a fall or fire and immediately raise an alert. We can have factory or warehouse robots taking readings and applying AI algorithms to identify patterns that predict equipment breakdown. We're also all familiar with smart home systems like Alexa, etc., and even very advanced systems like autonomous cars where edge can be incorporated to provide a variety of functionalities. So now that we know about the capabilities and importance of edge devices, let's take a brief look at some of the current industry offerings for computation on the edge. Listed here are some of the most notable ones. Google's Coral Dev Board, launched recently, offers a TPU in its hardware for carrying out complex computational tasks. NVIDIA's Jetson family also offers a family of devices and has support for a wide variety of machine learning frameworks. From Huawei, the latest offering is the Atlas series, powered by the Ascend AI processors. The Ascend chipset consists of NPU, which is a dedicated processor designed for performing neural net computations. This illustrates Huawei's offering of the full stack all scenario AI products, including module, card, edge station, server, and cluster, all powered by the Ascend AI processors to build an all scenario AI infrastructure solution across cloud, edge device, and training cluster. For inference, these are our edge products based on the Ascend 310 chip. Note that we cannot perform model training on edge devices, only inferencing powered by AI accelerators and useful for several embedded applications. The Atlas 200 Developer Kit is a high-performance application development board to facilitate quick development and verification. The Atlas 500 Edge Station is an industry-level edge device offering. It's more resilient in general and can support a variety of industry applications. Next, let's look at some examples of how and where edge devices are used in industry. The first intelligent grid inspection system combines the power of data training on the cloud and subsequent model deployment on the Atlas Edge device for real-time analysis and alerting. Since the system uses efficient edge computing for local processing, the power consumption reduces by close to 80%. Another example of cloud edge collaboration is for model training and deployment, enabling intelligent quality inspection for solar PV modules in the factory. Comparing manual inspection, which provides only 33% accuracy, versus 100% accuracy rate in a much shorter time duration by using this technology. The Atlas Edge device has also been leveraged to improve medical diagnosis in terms of precision and duration as compared to manual diagnosis.